Hello there, math kids. This is Mrs. Gillihan once again, and we are working on task 1.6. This is problem number 7 in your homework, and the instructions are asking us here to find, you are given two consecutive terms in an arithmetic sequence, and it's your job to find the recursive function and to also find two of the missing terms. We're looking for f of 5 and f of 6 in this instance. And the interesting part about this is basically we're presented the information using function notation. So if f of 3 equals 5 and f of 4 equals 8, that communication there means that our third term, the third term in the sequence, is 5. That's what that is telling us. And in this case here, it's telling us that the fourth term in the sequence is 8. And hopefully you can start to see a pattern, but a really good way of keeping organized is to take that information and we're going to put it into a table in order to see the pattern emerge. And so let's just start plugging that in. Our third term is 5, so let's just plug in 5 for the table right here. And because our fourth term is 8, let's go ahead and plug in an 8 for that term there. Now from here, because we are told it's an arithmetic sequence, we know there is a common difference. And the common difference, of course, from 5 to 8, we had to add 3. So our common difference is 3 in this instance, and we are going to have to use that in order to continue to fill in the rest of the table. So let's start by filling in what we are being asked for. Term 5, or f of 5, equals, well, if we come down here and just continue the pattern and add 3, we know that the fifth term is going to be 11, and we could just plug that into the table, and we can also plug in 11 into our answer box over here. There we go. And again, the pattern continues. We're looking for f of 6 for the sixth number in the pattern. F of 6 will be, because we add 3, 14. Okay, so let's go ahead and add 14 to our table, and let's add 14 to our answer spot over here. Alright, so we have our fifth and sixth terms, and again, read out loud, that's f of 5 equals 11, and f of 6 equals 14. Alright, and now we're being asked the second part of this for the recursive function. Now remember, a recursive function always has two lines, and it basically communicates two pieces of information. The first piece of information, the starting point. What is term number 1? You always have to communicate where exactly this whole sequence began. And we notice that term number 1 over here in the table, still empty, not quite sure what that is yet, but we can use the pattern to help us find that. So let's take a look at the 5 and help kind of back our way to term number 1. So if term number 3 is 5, then that means that term number 2 has to be 3 less than that, because we want this number to be added to 3 in order to get to 5. So that means that the second term has to be 2. Because 2 plus 3 equals 5. Okay? And we can just continue with that process. We know we need a number here in the first term, so that when we add 3 to that term, we end up at 2. And we know that that is -1. So our first term in this case, term number 1, is 1. And so now we basically have all of the information that we need in order to create a recursive function. A recursive function always starts by telling us what that very first term is. And this says f of 1 equals -1. So our first term equals -1, and we can see that over here in the table. The second line of a recursive function always includes what exactly is happening step by step. Alright, so what this is saying is f of n, which means any number in the sequence can be found by taking f of n minus 1, or the term previous to that, and simply adding 3 to it. So this is where we find our common difference, and over here is where we find our first term. Okay, so two pieces of information that are communicated in that recursive function for an arithmetic sequence.